Let's get some extra marks for Module 2. Our first one, we're looking at forces in strings. So standard case scenario, we've got a couple of hanging masses and a couple of sliding masses. We are going to ignore friction for the time being. As long as you're super methodical with your approach for these types of questions, they're all the same. So let's go about making ourselves familiar with this methodical approach. So first step is to come up with an expression for the net force on the system.
That isn't what you're thinking.
We say the net force is the sum of all of the assistive forces minus the sum of all of the resistive forces. In this type of question, there's only assistive forces acting, and that is the weight forces due to the hanging masses.
Because we got no friction, baby.
So the net force on the entire system is 98 newtons. Super important, you recognize it's on the entire system. So to find the acceleration of the system, we need to divide by the mass of the system. We've just found the acceleration of the entire system, and we make the assumption that all of the objects in the system experience the same acceleration. Seeing as all objects experience this acceleration, we can use Newton's second law to figure out the net forces on all of the objects in the system. We've now figured out the net forces acting on all 4 objects in the system.
Goodbye, ass.
Now let's think about the individual forces acting on the objects and come up with expressions for net force. Let me label some tensions. Pro tip, this is one long string. We assume that tension is uniform in a long string. Now let's think about the forces acting on my 6 kilo object. Remember, tension is the weird force. It's the one that changes direction depending on how you look at it. But just remember, tension always acts away from the object you're analyzing. So for the 6 kilo object, which way would tension be acting? Correct, it would be acting vertically upwards. So with that information, we can then figure out an expression for net force on my 6 kilo object. Just consider, if I was to let all these masses go at the same time, which way would the system move? I would expect my 4 and 6 kilos to move down. I would expect my 2 and 3 kilos to move towards the right. So when I'm analyzing the 6 kilo object, any force down is assisting its motion, any force up is resisting its motion. The only force down on my 6 kilo object is the weight force of the 6 kilo object. The only force up on my 6 kilo object is the tension force in the string, T1 that is. I can then figure out my tension force T1 is 19.6 newtons. Now we can do the same thing for the 4 kilo object. So how does this tension force impact the 4 kilo object? Remember, tension always acts away from the object. So according to the 4 kilo object, the tension force is actually pulling it down. So tension is actually down. That means for the 4 kilo object, tension is actually an assistive force rather than a resistive force because it's supporting its motion. So there's actually 2 assistive forces for the 4 kilo. The weight force of the 4 kilo plus the tension T1. So we've now come up with an expression that only has one unknown, that is T2. We can rearrange and solve for T2. That's our tension in the long bit of string that goes across the pulley. We've now determined the tension in string 2 to be 32.67 newtons. Let's continue and find out the tension in string 3. Okay, remember we assume there's no frictional losses or anything inside the pulley.
Because we got no friction, baby.
So tension T2 up there is equal to tension T2 over there. Now again, assuming there's no friction,
Because we got no friction, baby.
the only resistive force acting on the 3 kilo block is tension T3. We've already determined the net force on the 3 kilo object. We now recognize it's simply just the difference between the assistive force T2, the resistive force T3. We know the value of T2. This allows us to figure out T3. We've now determined the tension in T3 to be just a little bit over 13 newtons. Let's make sure this makes sense. Consider the very last block, our 2 kilo block. Now there's only one force acting on that object,
Because we got no friction, baby.
and that is the tension in string 3. So we would expect that T3 is the net force on the 2 kilo object. And we see that we've worked it out previously, they are exactly the same. This hopefully makes us feel good about our answer. Easy peasy. Extra mark for you guys.